The Airbus company, an international alliance of many aviation companies, came into being in the early 1970s and has grown steadily in stature until now, when most of the world's airlines fly some of the Airbus range of aircraft. There has been a design genesis that has encompassed short-haul, mid-range and long-haul solutions, and some notable variants. We investigate just how this success story has come to pass by focusing on the planes that are Airbus. As soon as Wilbur and Orville Wright had landed and retrieved their craft at Kitty Hawk in the USA in the early part of the last century, the next questions were raised. Higher, further, faster, better. They had begun a chain of events that would change the world. There was a dramatic increase in the number and types of flying machines, some weird, some wonderful, but all exploring ways of getting men into the air in a powered and controlled manner. Power and control were the main issues, and once the basic elements of taking off and landing had been mastered, the aspect of control became the next obstacle to aircraft development. World War I saw a rapid increase in technology as the warring nations sought to harness the advantage of powered flight. Britain, France, Germany and the USA formed their own air corps and produced relatively robust, efficient and fighting machines. The wood, string, levers, wire and cloth had become lethal weapons in their own right. The first transatlantic crossing in 1919 by the intrepid Englishmen Alcock and Brown in their slightly modified Vickers Vimy bomber aircraft caught the eye of the general public. Aircraft became fashionable and exhilarating fancies for those who could afford and dare to fly them, and air travel became a viable prospect. Aircraft that could carry a reasonable number of people as well as mail began to emerge, and with them blossomed the airline industry. To travel further with more people, bigger aircraft with more engines were built. The open cockpit, wood, stick and wire, giving way to aluminium, glass and complex controls. Airline comfort and elegance reached its peak with the huge seaplanes, setting more and more records for distance and comfort, relying on the water for their takeoff and landing. Civil aviation came to a sudden halt when World War II erupted. All focus was on the production of military machines, especially fighters and bombers. It was the accelerating development of the bomber with its need to carry a large payload over a long distance that formed the basis of design work for the new era of civil passenger aviation. But the jet fighters of the Luftwaffe and the RAF ushered in a new era of flying. Germany, France and England were almost bankrupt at the end of the conflict. Civil aviation was too much of a luxury, and European airlines initially had to make do with wartime aircraft. The manufacturing might of America had not suffered so badly, and so America was able to stake an early lead in the race to dominate the skies. Companies such as Boeing quickly used multi-engine propeller aircraft on internal flights, and the all-important transatlantic route became the key to large airline progress. European companies concentrated on smaller routes on the continent until the arrival of the de Havilland Comet in the late 1950s, the first jet airliner in commercial service. In quick succession, the aircraft companies of Britain, France, Germany and Europe began building short-haul jets that proved economical, comfortable, reliable and efficient. By the 1960s, the Americans were definitely world leaders in the long-haul jet airliner class. Their Boeing 707s, 727s and DC-8s had greater range and capacity than anything Europe could offer, apart from the Comet 4 and the ill-fated Brabazon. Britain and France had been building their own aircraft types for some time. The BAC 111 was a typical British design. The unusual Hawker-Siddeley Triton trijet and the sleek French Caravelle enjoyed some success with small European airlines and provided excellent jet airliner experience. But people were beginning to want to travel further, and it was the long-haul expansion that was evident, and that belonged almost solely to the Americans. In the mid-1960s, the EEC slowly came into being as European nation after nation signed up to the common market. The British and French governments recognized that working together could give better results, pooling ideas, technology, and expertise towards a common goal. Instead of trying to go bigger than the Americans, then why not go faster across the Atlantic? Enter Concorde, the world's first supersonic airliner. The Anglo-French creation was a technological masterpiece. Flying east to west across the Atlantic, you could actually land in New York 1 hour before you set off. The plane was applauded worldwide and won great acclaim for its designers, but it never became a commercial success. Air France and British Airways being the only airlines that ordered and operated Concorde. The American authorities initially made it difficult to obtain permission to land near New York, a harbinger of difficult times ahead. The seeds of European cooperation were sown, but the Americans still dominated the aviation industry. In 1967, French, German and British governments announced plans to build a European aircraft. The aim was also to challenge the Americans. However, a combination of politics, the economic legacy of Concorde, and the costly TSR-2 fiasco meant that 18 months later, the British government withdrew support. Hawker-Siddeley Aviation rather bravely funded the building and design of the wings themselves for the new Airbus, until the company was merged with BAC to become part of British Aerospace in 1977. At the Paris Air Show in May 1969, the A300B, the world's first twin-engine wide-body jet, is launched. It is to carry up to 250 passengers in a comfortable two-class layout, and later that year, Airbus secures its first potential order for 6 A300B2s, with a letter of intent from Air France. December of the same year saw the Airbus Industry GIE officially formed between Aerospatiale for France and a grouping of Germany's leading aircraft and manufacturing firms, later part of Deutsche Aerospace, with UFW Fokker of Holland and Hawker-Siddeley of Britain becoming associate partners. Airbus Industry was to provide a single sales, marketing and support network for Airbus customers. For the first time, Not only was a brand new aircraft about to be produced, a brand new company and business concept too was to emerge, spanning many nations, languages, customs and expertise. The allocation of building sections of the aircraft was closely scrutinized and based on existing skills in national companies. Deutsche AIRBUS near Hamburg had responsibility for the main fuselage. Hawker Siddeley in Britain began work on the wings. Aerospatiale in France were the main assembly point in Toulouse, with the cockpit and centre section being produced at Saint-Nazaire. A few years later, the Spanish company CASA would come on board to build the tailplanes in Madrid. In the late 60s and 70s, it must be remembered that there was not the technology available to today's designers. Wooden mock-ups were still made of the wings by Hawker Siddeley. Computer simulation, or CAD, was still a dream. Feet and inches, pounds and stones still vied with millimetres, kilograms and kilometres. Today, a designer can email or video conference immediately with a colleague in Toulouse or Holland. Information, queries and ideas can be shared instantaneously via the internet. Back in the late 60s and 70s, the slide rule was king, and the experience gained from the early jets and Concorde production became invaluable. Testing was generally done to destruction to ascertain stress capabilities, even simulating a bird strike using a special air cannon. And as none of the companies had successfully produced a wide-body jet airliner before, the risks were enormous. It wasn't just the technology that was needed to make this project happen. The people and expertise, both on the technical and management side, were equally as important. To successfully combine the skills, ideas, fears and strengths of several nations, companies required great tact, diplomacy and clarity of vision. In a series of groundbreaking moves with parallel moments of uncertainty and optimism, the first A300 began to take shape. It was the first wide-body jet of its type ever, and the first airliner ever to be built by several nations at once. Immediately, there were difficulties. The first choice engine, the Rolls-Royce RB211, was dropped after Rolls sold the design to the American TriStar jet and lost interest in the Airbus project. In a remarkable yet pragmatic turnaround, Airbus arranged to test the American-built General Electric CF engine on a B-52, found it to be remarkably fuel-efficient and powerful, and incorporated it into the design. The engines were further tested at extreme temperatures and conditions designed to highlight any possible flaws. The spirit of cooperation and dedication to the cause pushed Hawker Siddeley to introduce expensive new digital tooling machines, crude by today's standards, but at the time revolutionary and symbolic of the highly technical and energetic approach to the project. Wings were built in vertical jigs, with the leading and trailing edges fitted separately. Airbus pioneered the use of advanced composite materials on the A300B, and CASA in Spain began incorporating them in secondary structures such as tail fins and leading edges. Deutsche AIRBUS produced the central fuselage in huge jigs, again with little computerized technology, a testament to the skill and engineering expertise of all involved. A full sense of European cooperation was beginning to emerge, and there was a certain pride in being part of a new special international community. The sites were widespread. Hawker in Chester, England, Deutsche AIRBUS in Hamburg, Germany, Aerospatiale in Saint-Nazaire, northwestern France and Nantes, and of course the final Airbus assembly plant in Toulouse, southwestern France. Designing the separate sections and building them was one thing. Getting them to Toulouse for the final assembly was another. With their first aircraft in several pieces, and a letter of intent from Air France for 6 A300B2s, there was no time to spare. Obviously, air transport was needed to carry the sections to and from the various sites, and initial procurement made, but no one could wait for an aerial transporter to be built or adapted. So road transport and ferries were used. The huge loads caused a lot of excitement and chaos on the road, as phone lines, power lines and trees were always an obstacle. But the sections had to get through to the plant for assembly. Many people watching the spectacle did not comprehend that they were seeing the unification of a pan-European project, as the huge loads gently nudged their way through villages and towns day and night. This is still the case even today on routes to and from the airports. Conscious of the need for speed in 1972, and again with remarkable boldness, to improve the transportation process, Airbus bought and modified an American Boeing Stratocruiser, followed quickly by 3 more. In 1972, these 4 Super Guppies began commuting between the Airbus plants. The transporters were powered by 4 Allison 501 propeller turbines, derived from the Boeing model B377, and also used in the NASA spaceflight programs. As Airbus Industries grew with rising production rates, the Guppies eventually arrived at the limit of their capacity and age. So, Deutsche Airbus and Aerospatiale formed the Special Aircraft Transport International Company, SATIC, in October 1991, and began to develop one of their own aircraft to become the new supertransporter. This arcane but practical transportation got the parts of the first Airbus A300 to the Toulouse plant, and work began on assembling them immediately. 1972 was a busy year for Airbus on many fronts. True to its original concept, Airbus International was not just building aircraft, it was selling them too. Mock-ups of the interiors were made to show prospective customers what could be done with this wide-bodied airliner. Training of pilots began in earnest with the A300 simulator, setting in motion the practice of allowing pilots to cross-train from type to type with less difficulty and introducing the early concept of commonality. A short time after assembly began, Air France officially became Airbus's first customer, placing a firm order for 6 A300B2s, a 270-seat stretch version of the original A300B they originally requested. This order was followed sometime later by Spain's Iberian Airways. In January 1972, the Spanish company CASA is officially awarded the contract to build the horizontal tail parts of the aircraft and joins the consortium, taking a 4.2% stake and developing the use of weight-saving new composite materials. As production of the A300 continued apace, the A300B4, a longer-range version of the A300, was launched, with a range of 3,000 nautical miles compared to the 1,200 nautical miles of the original A300. Its maximum takeoff weight at 165 tons is also greater than that of the A300B2. As well as the introduction of the composite sections of the aircraft's fin, leading and trailing edges and radome, the A300 also featured advanced rear-loaded aerofoil, giving a greater aerodynamic efficiency of the wing, and full flight regime auto-throttle and automatic wind shear protection, putting it well ahead of its competitors. The rollout was performed jointly with the appearance of Concorde Mark II. A300 was the airline industry's first twin-engine wide-bodied aircraft, and it soon began to be noticed. Detailed testing of all areas followed. The cabin resistance to air pressure was calibrated. Foam blocks were used to reduce the volume of interior space, so less air is needed and a more accurate result obtained. In these pre-computer design days, hydraulic rams were used to simulate and exceed the stresses that could be imposed upon the airframe. Early punch code computers recorded the data. The A300's maiden flight took place on October the 28th, a month ahead of schedule, despite several delays due to bad weather. The flight crew of Captain Max Fischl, Bernard Ziegler, Gunther Scherer, Pierre Canel and Romeo Zinzoni nervously began pre-flight checks. The A300, the first Airbus aircraft and first wide-body twin-engine jetliner, took off at 10:30 a.m. local time from Toulouse Airport for a mission lasting for 1 hour and 23 minutes. A thorough in-flight check of all systems was undertaken, both on board the aircraft and from the supporting teams. Landing was greeted with relief and exhilaration. The flight crew were delighted with the aircraft's performance. Much of 1973 was given over to flight testing and evaluation, and the production line began to expand. In March 1974, the A300B2 received certification from French and German aviation authorities, ahead of schedule and on budget, which meant it could be delivered to its new owners. Air France took delivery on the 10th of May, entering the A300B2 into service on the 23rd by flying from Paris to London. The aircraft now began a whistle-stop sales tour of the world's possible clients, landing and taking off at major airports and air shows around the globe, especially North and South America. Nothing sells an aircraft like the aircraft itself, and the orders start to roll in as the Airbus story accelerates. It shows it can perform well at high-altitude airports, as well as deal with the extremes of temperature. The aircraft is well received wherever it goes, and interest is high. Many European countries around this time start to look at the environmental issues of aircraft. not least because of the 1973 fuel crisis. Most of the earlier jet airliners were very thirsty, noisy and dirty. The earlier built American jets such as the 707 and 727 particularly had loud and dirty emissions. The A300 with its two fan-based General Electric engines was cleaner, much more fuel efficient and a lot quieter. The original whispering giant. In September 1974, Korean Airlines becomes the first non-European airline to place an order with Airbus for 4 A300B4s. Certification of the A300B1, the original 250-seater, is followed later in November by the first delivery of the aircraft to Trans-European Airways. And the following month, December 1974, the longer-range A300B4 successfully completed its first flight, and certification followed in a few months. Across the Atlantic, certification by the American Federal Aviation Administration was finally given. The gateway to the lucrative American market appeared to be opening. The A300 in different guises is proving itself extremely popular and tours extensively in the USA. But American sales are not forthcoming. There are already a lot of functional aircraft across America, and the size of the industry with its ties to powerful figures, businesses and political prevarication stalls interest in this aircraft. However, in April 1975, Indian Airlines orders 3 A300B2s, making this the first contract to be secured by Airbus in a country previously dominated by American aircraft manufacturers. The door to the larger market is now opening wider. As Britain sweltered in the heat of the 1976 summer, sales of Airbus 300 virtually stopped. The initial success in the medium-haul passenger market had been outstanding, but not sustained. Development work, however, was forging ahead, and the CAT 3A Autoland system was added to the A300, allowing the aircraft to land automatically in poor visibility. It took a former NASA astronaut, Frank Borman, heading up the Eastern Airlines, to be the first American airline to step up to the mark and take a leasing deal on 4 A300s in May 1977. The US market had started to crack, and 11 months later, when the Eastern ordered 23 A300s with a further 9 on option, the rest of the world finally began to take the Airbus consortium seriously. More orders came quickly, and Airbus became established as a lead player in the airline business. As the product range was developing, taking on board new technical innovations and adapting to more markets and customer demand, so the company itself was developing. The British air industry in the late 1970s underwent a major shake-up, and after several mergers and acquisitions, including the takeover of Hawker Siddeley, British Aerospace was formed, and joined Airbus Industries in 1979 as a full partner, taking a 20% share, raising the profile and capability of the European venture and firmly uniting Europe's leading aircraft manufacturers. Just prior to this, the smaller but longer range A310 was launched, with even more technological advances. With the A300-600 and A310, Airbus first develops the concept of commonality. This meant that for the first time, a twin-aisle aircraft could be piloted by a two-man crew, using instruments located in front and above, without the need for a third crew member, usually referred to as the flight engineer. The introduction of cathode ray tubes, or CRTs, was also a revolutionary innovation. The old dials and needles were soon to become a thing of the past. Airlines around the world began placing orders for this aircraft, from Saudi Arabia to American Airlines. Airbus established its presence worldwide and as a world leader. The aircraft industry has its own idiosyncrasies. Large freight carriers such as FedEx, UPS, DHL, TNT and others were looking for a freighter, and they selected the 222-inch fuselage cross-section for the original A300B jetliner. This sizing not only created one of the most comfortable passenger cabins ever designed, it also provided spacious lower deck holds, capable of accommodating the industry-standard LD3 containers side by side, or standard pallets, as well as a voluminous main deck with excellent cargo capacity. An A300B4 configured as a freighter has a 43 metric ton cargo capacity at a range of over 2,000 nautical miles, 3,700 kilometers. And 1978 sees the launch of the convertible A300B4 passenger cargo aircraft, aimed at the developing Middle and Far Eastern countries. These additional markets were to prove useful to Airbus Industries as the passenger markets fluctuated in their buying cycles. The A310, seating 218 passengers, aims to offer airlines a smaller, longer-range alternative to the A300. Its launch shows Airbus to be more than a one-aircraft manufacturer. The commonality factor means that essential parts, sections, procedures and training can be shared by aircrew and ground crew, not only saving on initial cost, but also increasing enormously the after-sales support and service offered by the company in all parts of the world. Airbus again went up a gear in the eyes of the world's major airlines. In 1981, the first A310-200 rolls off the final assembly line in Toulouse, almost 10 years after the rollout of the first Airbus aircraft, the A300B. Only 6 computers are needed to run the aircraft's autopilot, autothrust and flight director, as opposed to the 18 computers required on the A300B2 and A300B4, which used analog technology. The A310-200 entered service with Swiss Air in April 1983, and almost immediately the go-ahead is given for the A310-300, which again incorporated new innovations, such as using composites in primary structures like the fin, and becoming the first civil aircraft to feature the drag-reducing wingtip extensions. Within the family structure, the longer-range A300-600R has been developed, giving longer range and aimed at a definite market, the Americans. From the early, heady days of optimistic dreams and challenging political and technical reality, the team at Airbus has ushered in a new era of aircraft, broken into new and bigger markets, and proved themselves capable of taking their place at the leading edge of aircraft design, manufacture, production and delivery. And the story is only just beginning. Having begun to establish itself as a world player, Airbus looked at the medium-haul range in different areas of the world, and to replace the aging global fleet of existing aircraft, they set about designing the A320 family of twin-engined, single-aisle, wide-bodied jets. The A320 was revolutionary in many aspects. It was the first to be completely designed on computer, the first to make significant use of composites in major parts of its airframe. It introduced the forward-facing cockpit with cathode ray screens, and it was the first to feature fly-by-wire technology. To keep up the momentum of the development cycle, one A300 was fitted with most of the new technical systems, including fly-by-wire, and advanced technical apparatus which help speed up flight testing and monitor results. In Toulouse 1986, the A320 began to take shape, the parts, as before, arriving from different European countries. CASA in Spain increasing the use of composites in the tail section. The engines chosen for this smaller jet were the Smegma GE CFM56 turbofan and International Aero Engines V2500. Section by section, the plane was assembled and tested on the ground. Resting on its own undercarriage is just one of the major steps for a new airliner. Prior to painting or public rollout and first flight, the aircraft is fitted with engines of the same weight to aid structural testing. These will be changed for the CFM56s later in December of this year. The maiden flight takes place early next year, February 1987. Europe's Airbus 320, the third airliner of the range so far, is about to take to the skies for the first time. Past success with the A300 and 310 aircraft, and Airbus's reputation, mean that orders for the new jet are already accumulating. The highest ever figure of orders placed, 600 so far, before the aircraft completes its commercial certification program. Happily, the maiden flight is completed without any major problems, and certification and marketing begin. The earlier work on the A300 testbed accelerates the testing, as does the use of advanced technology on the ground and the air to process results. Certification can demand some extreme situations. The aircraft has to cope with flooded runways and maintain control with enough power to land safely. Extreme can also mean cold, very cold. The Arctic wastes of Sweden provide night temperatures of below -20 degrees centigrade. After a night and a day in these conditions, the aircraft is found to be working perfectly. One of the more dramatic tests involves the skid rail and rear fuselage testing, as well as repeat heavy landing and takeoffs with the undercarriage. Even the earlier air cannon is used to simulate bird strikes against the windshield, and the engines also undergo stringent testing with foreign objects. One important aspect of the A320 testing involves monitoring the crew for stress and behavior patterns with the new technologies. All these and more tests are thoroughly applied, and finally the aircraft receives its certification. Rollout of a new aircraft is a very prestigious affair. akin to the launching of the great ocean liners of the past, especially when Airbus is the symbol of European cooperation and technical expertise. Dignitaries from all over Europe and the world's media welcomed the dramatic rollout of the A320. With the order books filling up and airlines from many nations taking up the short to medium-haul aircraft, production went into top gear. The various companies from around Europe producing the respective parts, transporting them with the supertransporter and assembling them in Toulouse. The technical innovations of this aircraft allowed it to be flown easily and efficiently on many routes, expanding air travel even further. Production of the A320 rose to 10 aircraft per month as the world's airlines began to exploit the emerging short-haul market, competing directly with road and rail transport. Once the air industry's underdog, the fortunes of Airbus were improving dramatically. The A320 was the first civilian airliner to introduce fly-by-wire technology, a massive step forward in control and safety in the air. In the early years of flight, sheer muscle power was all that was needed to operate the stick that controlled the aircraft surfaces. As aircraft grew larger, the control surfaces became bigger, and forces generated were too great for mere muscle. Some ingenious designs were incorporated to help this. One of the earliest steps to assisted flight control was with the flying boats. The wheels and pulleys involved became quite common in many aircraft of the time to deal with the sheer muscle power needed to maneuver these craft. Some seaplanes began to use electrical servo assistance for the control surfaces. With bigger aircraft and the civil aviation expansion in the 1950s, more control was needed. The Princess used electric servos to operate the different surfaces. Without these, she would not be capable of maintaining any flight stability or control. Soon, nearly all aircraft were using servos of one kind or another to operate the flaps, rudders and tail areas. These surfaces were, however, still linked to a complicated matrix of mechanical levers, rods and hydraulic motors activated by electrical signals. The next logical step was to link the motors that moved the control surfaces to the cockpit by electrical wire. This was much simpler, lighter and safer. This also meant that the traditional columns or control yokes could be replaced by smaller side sticks. This revolutionary leap forward, along with the new display systems and forward-facing cabin, made the A320 the most technologically advanced airliner of its time.
I love flying our fly-by-wire aeroplanes.
William Wainwright, chief test pilot at the time for Airbus, takes us through some of the features of fly-by-wire.
Now we have electric signalling. I'm back to my small side stick, which I move with my fingertips, just like that. That moves the aeroplane. To illustrate what I mean about going to maximum performance easily, let's just slow down to our so-called alpha max, which is just before the stall. First of all, I need to reduce the engine thrust. Then the aeroplane slows down and but still with quite light forces. I pull the stick fully back, and I keep pulling it back. There we are. Going back towards 100 knots. And now all I'm doing is holding the stick fully back, and the aeroplane will stabilize just above the stall. Feel it's buffeting a little bit. That shows that we're not very far away from the stall, but we won't stall. We can sit there all day.
Safety is obviously of paramount importance, and in order to ensure that there are no technical failures with these systems, 5 separate computers are used in the control system, each individually capable of assisting the pilot, and to provide even greater redundancy insurance, each computer is comprised of 2 units, one monitoring the other. To provide an additional level of security, the computers are designed and built by different manufacturers and programmed by different software teams, so that any unforeseen technical faults will not affect all the computers on board. They also have a direct benefit to the human element of flight.
They help me by making the aeroplane much more pleasant to fly. They smooth out all the nasty characteristics that some aeroplanes have, like big trim changes with speed or weight, changes in pitching and moments with applications of thrust. That can all be taken out by these computers.
The computer systems also introduce the benefits of commonality in the Airbus family, making the aircraft very similar to fly. There are also several benefits to airline companies with this kind of technology. This commonality of flight systems was also applied to the airframe, and the adaptability of the A320 is evident in later models. In March 1988, Air France took delivery of the first A320. The airline had placed 25 firm orders for the technologically advanced single-aisle fly-by-wire aircraft, with 25 options, and planned to use the A320 on its European routes, seating 153 passengers, 27 in business class and 126 in economy. The A320 was the first single-aisle airliner to feature a wide fuselage, offering more comfort to passengers in the cabin, with wider seats and a wider aisle. Furthermore, the superior cabin size and shape allowed large overhead storage to be fitted for faster boarding and deplaning, as well as greater convenience. The A321 seats 185 passengers and has a range of just under 4,500 kilometers. It was launched in November 1989 and flew for the first time in Hamburg in March 1993, where it is to be manufactured. Longer and carrying more passengers farther, the A321 was ideally suited to the medium haul runs, both in Europe and the USA. Because it is also used in the same cockpit, flight systems, engine and cabin as the established A320, airlines also receive better parts and backup service. May 1993 also saw Airbus launch another member of the A320 family, the A319, a smaller version of the A320, seating 124 passengers. Again, sharing commonality with the A320 and A321 enabled all 3 aircraft to be operated effectively as a single type, leading to significant savings for airlines. Further savings are obtained through cross-crew qualifications with the A330 and A340. The Airbus family in production capacity continued to grow. And on August 25, 1995, as it completes its successful maiden flight, only one day after its rollout, Airbus announces that it has firm advance orders for 81 A319s, orders for 905 aircraft from 43 customers for the A319, 320 and 321 family. To help with this increase in orders and production, the A300-600 Super Transporter, which will become known as the Beluga because of its distinctive shape, was launched in August 1991, with the aim of transporting components for Airbus aircraft around Europe faster and more efficiently. The Super Transporter has twice the payload of its predecessor, the Super Guppy, and can transport the sections of a complete Airbus in less than half the flying time of the Super Guppy. With a range of up to 3,250 nautical miles, 6,000 kilometres, the A318 offered with CFM56 engines or Pratt & Whitney PW600A engines entered service in July 2003 and typically accommodates 107 passengers in a two-class layout and up to 132 passengers in a single-class layout. The wider fuselage also provided unmatched cargo capability, and the A319, A320 and A321 are unique in their category in offering a containerized cargo loading system that is essential for profitable cargo operations. This system is compatible with the worldwide standard wide-body system, which reduces ground equipment and handling costs. The A318 has unbeatable takeoff and landing performance, requiring less runway length than comparable aircraft, and therefore provides operators with access to a greater diversity of airfields. Furthermore, the A318 has been certified for steep approach operations in May 2006, opening up further airfield possibilities. When combined with its ultra-low noise characteristics, these features make the A318 an extremely good neighbour for downtown airports. With the integration of its first A318 into its fleet, Air France is the first ever airline to operate the complete Airbus A320 family. Production of the short to mid-range fleet was reaching a staggering 12 aircraft per month, and the medium to long-haul market was also taking off. As designs, launches and rollouts of new models leapfrogged over each other, in time it became evident that Airbus had reached a firm position in the market, and so began to expand its range even further. The international companies involved also became established, working towards common goals and sharing information on an unprecedented scale. The new family of A330s and A340s were aimed at the medium to long haul and also the very long haul market. The common use of fuselage, cockpit and main wing meant that Airbus could cut development costs and time. Customers could also achieve greater reliability, efficiency and service. Savings were made in spares, training and maintenance, as well as operating costs. The main difference between the types was based on the number of engines, and at the time of launching these models, much technical research was conducted to achieve maximum efficiency in this market, explained here by one of the early design engineers.
We'll start with a common airframe featuring a twin-aisle fuselage seating 300 passengers and dimensionally identical wings and tail surfaces. And we'll look at the three configurations currently offered to airlines: the twin, the quad, and the tri-jet. Extra weight at the back there, both due to the engine itself and the need to strengthen the rear fuselage to carry it. So to redress the balance, the wing must be placed further aft. Now, the length of the moment arm and the dimensions of the tail surfaces are directly linked. If the moment arm is shortened, it'll reduce the tail's efficiency. To compensate, we need either bigger, draggier tail surfaces or a complex full-time longitudinal stability augmentation system.
So Airbus concentrated on two designs, the twin-engined wide-body A330 and the four-engined wide-body A340.
If four engines are reduced to two, the two will need to be larger, much larger in the case of the twin designed for very long ranges. Why? Because the extremely heavy load carried calls not only for high power, but for very high reserve power to meet the single engine out requirement. In a twin, an engine failure results in a 50% power loss. And for the long-range twin, this must be offset by very high thrust indeed, on one side only. The quad is much less affected, with one engine representing only 25% of the installed thrust, and the reserve power is more evenly distributed. The imbalance that both aircraft now suffer must be compensated for by the rudder. The long-range twin rudder has a much more demanding task and must be made bigger, and the consequence? Higher drag in the cruise.
Research and development to match potential customer requirements was begun as early as 1987. And as a testament to Airbus's information flow, input was also included from airlines' own representatives. The increasing use of better computer design systems and electronic communications built on the earlier technological advances and helped enormously in decreasing testing time and refining production methods. The very early methods of wooden mock-ups, cabin interior construction and expensive wind tunnel tests began to look very dated. To house such a large enterprise, another production facility was commissioned and additional investment raised for the next stage of the Airbus expansion. The main production area for the 330-340 at Toulouse became the largest single-span building in Europe. Called Clément d'Avion, after the French aviation pioneer who invented the word avion, this massive building heralded the next expansion phase of Airbus Industries. The production techniques were developing, as was the partner base. Now using a modular assembly process instead of the traditional production line, parts of the Airbus can be assembled in different hangars and fitted together at specific production points. The influence of new technology is evident as robots and computers are now heavily used in the design process, cutting and assembly. British Aerospace at Chester builds the wings for the A330-340 program, although final assembly is now done by Deutsche Airbus in Germany. Deutsche Airbus, as part of the Deutsche Aerospace, assemble fuselages in Bremen and Hamburg, as well as assembling the A321. Aerospatiale also produced several sub-assemblies such as cockpits and central sections, as well as final aircraft assembly in Toulouse. CASA in Spain have increased their workload especially with their high-tech composite parts. But Airbus has also expanded its partner base to include wider international partners, such as Bell Airbus, who produce these honeycomb parts. Canard Air in Montreal and even Australian companies are now important subcontractors to British Aerospace and the Airbus program. Even as far afield as South Korea, parts are made for Airbus. There are several engine types for the A330-340 program. CFM56-5CUs are for the A340, while the A330 has a range of engine choices. CF6-80E1s, Pratt & Whitney 4000s and Rolls-Royce Trent 700s. The scale of production meant that the Super Guppy fleet was still employed to ferry parts around Europe. But on the intercontinental routes, the Soviet-built Super Anatov was used to carry sub-assemblies. Again, trucks were used for shorter sections. The Super Transporter came into service and was in constant use, ferrying sections of the new aircraft around Europe, from manufacturing centres to assembly plants in Toulouse, Nantes and Saint-Nazaire. The A340 was the first four-engined long-range aircraft to be developed in 25 years, and production of this aircraft and the whole Airbus Corporation now stepped up a gear. This speeded-up film shows some of the processes involved as the aircraft is assembled prior to rollout and testing. Structural testing of fuselage, wings and other main parts is carried out on the ground at various points in construction. The aircraft frame is subjected to extreme physical stresses. The stretching, compressing and bending designed to test the construction beyond any limits it may encounter in flight. Its wings are bent to incredible angles until they finally break. After testing on the surfaces, the aircraft is rolled into the next hangar. The engines are added and more testing done on the frame, hydraulics and engines. These engines have to endure bird strikes, excessive water and ice. All of the new components and features, such as the increasing use of composite materials, have to demonstrate their individual capability and are monitored not only by the Civil Aviation Authority, but by Airbus engineers, so that future models can benefit from the accumulated data. Only after these tests have been passed and full accreditation given to the results can the aircraft be rolled out for its first flight. Airbus 340 No. 1 was given her ground roll clearance in April 1991. More tests were conducted, and after full verification was given her new paint job before the public launch later that year. Once again, the media and marketing departments got behind the launch of a new Airbus. The A340 was launched to the public in great style, sending a clear message to the airlines of the world that Airbus was up there with the long-haul big boys and here to stay. Autumn 1991, and it's time to see if the engineers, designers and test teams have got it right. On October the 24th, 1991, all doubts were dispelled as the 255 tons of the A340-300 took off and successfully completed all of her inaugural in-flight tests. To increase range, the wings had been reinforced to carry more fuel and improved aerodynamically to cope with the increased takeoff weight. With the 330 and 340 family, it was easy to follow some of the manufacturing commonalities typical of the range. All 330 and 340 types shared the same 5.64 metre diameter fuselage, despite different engine configurations, range and capacity. The A330-200 and 330-300 also shared exactly the same wingspan of 60.30 metres, although the 300 variant was just under a metre shorter and could carry 44 more seats. The 340-200 obviously had 4 engines, but exactly the same wingspan of the 330s. The same fuselage, although a different length, similar cockpit, and carried 240 passengers, and had a range of around 9,000 nautical miles. Its sister plane, the 340-300, was just over a metre longer, had the same wingspan, carried 295 seats, and had a range of 7,400 nautical miles. 340-600 and 500 shared the same wingspan at 63.45 metres, although the slightly shorter 500 at 67.9 metres had the longer range of 10,000 nautical miles. Cabin interiors could be configured in several ways, from the smaller, medium-range 330 to the full capacity of the four-engined long-haul A340, which has luxury class, 6 abreast business class and 8 abreast economy class. And to help with possible 12-hour flights, there are also rest areas for aircrew. With an eye on the American domination of the long-haul flight, Airbus set out to prove the long-range capacity and reliability of their new A340. The A340 World Ranger was to fly non-stop from Paris to New Zealand, refuel there and return.
Up comes the undercarriage. We're climbing. Le Bourget, Paris, all that's behind us. In front of us there's nearly 20,000 kilometres to fly. From now on, the crew and technicians are intrigued to find out if it will all go as planned. They know, and I am learning, what difficulties we could face and what sort of problems could arise. This is all linked to the fact that our flight is so unusual. Good news. The flight controllers have authorized us to fly direct to Lübeck. The sky's cloudy, but we can just catch a fleeting glimpse of life down there, far off on the left where the sun is going down.
World record non-stop flight attempt. A flight of more than 19,000 kilometers. The Airbus A340 took off at noon from Le Bourget, en route for Auckland in New Zealand. On board, France Info's special correspondent, Michel Polico. He called us a few hours ago when the Airbus was over Siberia. Michel Polico.
You can't imagine what it's like to be only 20 in an immense aircraft, where there's no decoration or fitting out as in a normal plane. There's no lining on the sides of the fuselage, hardly anything on the floor, no carpets. We're walking on the floorboard plates. A few seats have been installed so we can sit down. There's a big palette fixed to a rack in the middle of the aircraft, and that's where we get our little meal trays and tins of Coca-Cola. That's what they gave us for lunch a little while ago. The rear of the aircraft is completely empty and we can walk around. Oh, and among other things, most of the passengers and crew have taken off their ties. We flew over St. Petersburg at 14:30 hours. We're now in the north of the Urals.
A French Airbus A340 touched down at Auckland Airport a short time ago, making aviation history as it did. We managed to catch up with them, though, in the short time they're there. Joining us now from the airport, in fact, from inside the plane itself, is test pilot Nick Warner. Welcome to New Zealand. How are you feeling after your flight?
Thanks very much, Maggie. We're delighted to be here. We're feeling actually relatively relaxed and refreshed, and at the moment we're filling the plane up to hopefully take off in about an hour and a half back to Paris.
The Airbus A340, which is attempting to fly around the world in less than 48 hours, has already established a record.
The Airbus A340, which took off from Le Bourget yesterday, has already broken the world record for distance flown non-stop.
The plane landed around 9:30 Paris time as planned at Auckland, New Zealand, on the other side of the world.
旅客機によるノンストップ飛行の世界記録樹立を目指してエアバスの新型機が
Rekordflug erfolgreich. Nach 21 Stunden und 23 Minuten Flugzeit.
El avión Airbus A340 fabricado por
They authorised a direct track, high-speed route, overflying London Airport straight into Le Bourget.
Pratiquement la verticale de l'aéroport londonien jusque sur le Bourget.
J'ai eu ce pincement au cœur formidable que l'on a aussi.
I had that fantastic feeling which you get from the maiden flight of a new aircraft.
Suddenly I had the impression of an honor I didn't deserve, of carrying in my hands, on my shoulders, the responsibility of the work, the enthusiasm, and the dreams of tens of thousands of workers and engineers.
The trip was a resounding success, the reception incredible, and the aeronautical kudos immeasurable. The Airbus family had grown in number and variation since its small beginnings. But building on success and keeping the common features that made Airbus a popular choice with airline carriers, now put the company in a position to successfully challenge the long-haul jumbos of its opposition. The dawn of the new millennium saw Airbus Industries launch its largest venture yet. The world had changed since Airbus began their story with the A300. Routes had become longer, more concern raised about the environmental impact. Operating costs had increased. Cheap budget airlines had made airline travel more popular. Airways and airports became more crowded, and the prize market of the very long-haul routes became a delicate balance of expectations and viability. With visionary boldness and pragmatic research, a new, bigger family of aircraft was conceived by Airbus Industries. The company had grown exponentially, and the infrastructure, skills and experience was in place. Was the market ready for the A380? Extensive research was conducted at many levels, including the average passenger's ideal requirements, airlines' preferences, existing airport capability, the competition, and a wide range of wider issues, intended to explore all the factors affecting such a huge investment. This flagship of the 21st century was designed to be produced with the very latest in technologies, materials, systems, and industrial processes. 555-seat A380 is the most advanced, spacious, and efficient airliner yet produced. It meets the most stringent international certification requirements and can carry 35% more passengers than its closest rival. In order to measure passenger reaction, vast cabin mock-ups were taken to 8 major cities on 3 continents, and the views of 1,200 frequent travellers, male and female, and from a range of cultures and nationalities were listened to. And with far more floor space available, the A380 enables airlines to deliver unparalleled comfort in every class, with rest areas, ambient lighting, bars, and more open space for passengers to stretch their legs. The A380 will provide passengers on major long-haul routes like London-Singapore and Los Angeles-Sydney with a new way of flying. The passenger may be the end user, but the airlines are the clients, and after the fullest ever consultation with potential airline companies, Airbus believe that with the A380 they can provide the solution for today and tomorrow's market requirements to satisfy airlines operating the world's major long-haul routes. Let's take a look at some of these benefits in more detail. Airbus believes that with passenger traffic expected to increase by some 5% per year over the next 20 years, and to triple by then, very large aircraft will reach some 3,400 flights a day out of 200 airports around the world, with about 70% of them likely to be clustered around just 25 airports. Early critics of the A380 design were pessimistic about where and how the aircraft could be operated from. Airports have an established infrastructure, and expansion or adaptation of these could be a very expensive and potentially unsurmountable hurdle. But from the conception of the A380 program, Airbus consulted with airport and aviation authorities and regulatory bodies to come up with the best possible design and performance characteristics to match their needs. The A380 was designed to meet the space and logistical restrictions imposed on airports today in an ever more regulated environment. Airports are already scheduling into their development plans billions of dollars worth of infrastructure improvements. The A380 is an asset to these plans. Its greater capacity reduces the need for airports to duplicate existing facilities to cope with the rise in demand.
If the opening ceremony was spectacular and the plane impressive, then the work being done elsewhere is truly amazing. Working just meters from one of the world's busiest runways and in the middle of a live airfield, engineers at Heathrow are working on a massive project to receive the new A380. Its wingspan is 15 meters or 50 feet longer than the biggest jumbos currently in service, and that's meant a complete rebuild of terminals for British Airports Authority in a race against time.
We're absolutely on schedule. Behind me is the new pier in Terminal 3. It will house 4 A380 aircraft stands and the gate rooms for the 500 or so passengers on each aircraft. This time next year this will be fully complete and we'll be ready for the first aircraft at Heathrow.
The piers to get passengers off not only need to be further apart, but two-storey to accommodate the double-decker Airbus. Parts of the runway and taxiways are having to be strengthened and widened, and with a capacity for more than 800 passengers, huge new baggage halls with long conveyor belts are being constructed. In total, BAA is spending £450 million to prepare for the arrival of the new craft. It's predicting that in 12 years' time, the A380 will account for 1 in 8 flights, and with landing slots at Heathrow full, it's seen as the only way of increasing passenger numbers.
This is an aircraft built for Heathrow. There's no two ways about it. We're going to see, I reckon, probably half the A380 operations in the world will be initially coming in and out of London Heathrow.
Virgin has ordered 6 of the craft, but at the launch in France yesterday, the airline still had concerns that other airports had been slow to follow Heathrow's lead.
Boarding the A380 will take no longer than existing large aircraft, and servicing the A380 will have minimal impact on current facilities, because its main deck lower doors and its ground service connection points are at a similar height to those of existing large aircraft. The environmental issues have also been addressed by Airbus. The A380 was designed with the stringent noise and pollution controls of modern airports in mind, and its environmental friendliness goes beyond noise reductions. Its extensive use of composites, a greater proportion than in any other aircraft, means reduced weight and therefore lower fuel consumption, around 12% lower than that of its nearest competitor. Indeed, the A380 will be the first long-haul aircraft to consume less than 3 litres of fuel per passenger over 100 kilometres, a rate comparable to an economical family car. Less fuel burn results in fewer emissions of gases into the atmosphere. Better aerodynamics and advanced technology means the A380 will be significantly quieter than other large aircraft, producing half the noise of its closest rival.
Look, the main thing that airports are going to need is to ensure that their runways and taxiways are strong enough to withstand the extra weight that's being carried on this aircraft, that they've got equipment to be able to unload baggage and load baggage, that the departure halls and arrival halls are able to cater for a larger number of people, that the baggage belts where people collect their baggage from at the end of the flight are able to carry maybe 20 or 30% more baggage because of the number of passengers that are on the aircraft. You'll actually find that with an aircraft like this, in the event of having to make an emergency landing, it can land pretty much at the same airports that a 747 can land at right now. What we saw, for example, this morning was that the aircraft didn't use anything like the full available length of the runway. So in the event that an aircraft had to make a landing for some sudden reason, either because of some medical illness on board or because of some engineering related issue, then there are any number of airports that they can land at.
With a lower fuel burn rate, the A380's cost per seat run at 15% less than the largest wide-body existing today, and the corresponding costs of the A380F, the freighter version, run at 20% less. Its ability to carry 555 passengers will provide vital extra capacity for airlines to meet the growing demand for air travel without having to increase the number of flights. It will also give them the flexibility they need to match capacity to demand more closely, helping them to maintain profitability in an ever more competitive market.
Virgin has ordered 6 of the craft, but at the launch in France yesterday, the airline still had concerns that other airports had been slow to follow Heathrow's lead.
Slots are full at Heathrow, slots are full at Gatwick, so there's only one way to go, and that is bigger planes. Now, the advantage of people actually living around Heathrow and Gatwick is that these planes are incredibly quiet. They're very fuel efficient, so they're an environmentally friendly plane as well, which is surprising when you think this is the biggest plane ever built.
But will people want to fly in such a huge craft? Shoppers in Newbury had mixed feelings.
I wouldn't step on it. I wouldn't go anywhere near it at all. I'm scared of flying anyway.
I'm used to checking in with large numbers, so it's only probably in a few more, so it wouldn't make a lot of difference.
The more modern the aeroplane is, the more efficient it's going to be. It's going to be comfortable.
But the Airbus, part owned by Farnborough-based BAE Systems, may be planning even greater things.
You see lots of customers around here, not only current customers but future customers as well. And the last thing I heard was, could we have one that's even bigger?
Let's take a look at some of the technological innovations of the aircraft and the production methods that are responsible for these amazing features. The A380 family starts from a baseline passenger aircraft with a capacity of 555 passengers in 3 classes and a range of up to 15,000 kilometers, 8,000 nautical miles. It has an overall length of 73 meters and a massive wingspan of 79.8 meters. The double-deck fuselage is 7.14 metres in diameter, and when on the ground, the aircraft has a height of 24.1 metres. The freighter version, the A380F, will carry a payload of 150 tonnes, 330,000 pounds, over 10,400 kilometres, 5,600 nautical miles. In true Airbus fashion, stretched, shorter and extended range variants of the baseline version will become available, as and when the market requires them. The A380 is powered by 4 Rolls-Royce Trent 900 engines, or 4 GP7200 engines from the Engine Alliance, a General Electric and Pratt & Whitney joint venture, delivering a thrust of up to 81,500 pounds, 37 tonnes each. To date, 6 A380 customers have selected the Engine Alliance GP7200 engine, for a total of 82 firm aircraft orders. The aircraft has a maximum takeoff weight of 560 tonnes, a maximum landing weight of 386 tonnes, and a maximum fuel capacity of 310,000 litres. Building on the success of its previous composite experience, some 25% of the aircraft is made from composites, 22% carbon fibre reinforced plastic, and 3% glare, a fibre metal laminate. And for the first time, not only are more primary structures made of composites than ever before, the centre wing box and rear fuselage are too. The growing number of pilots already qualified on Airbus fly-by-wire aircraft will feel right at home in the A380 flight deck, as it uses the same cockpit philosophy and operating procedures as the A320 and A330-340 families, whilst also benefiting from advances in technology for displays, flight management systems and navigation. The A380 cockpit has 8 identical large interactive displays on the main instrument panel, with cursor control provided through a trackball. The displays provide a much larger screen area with clearer presentations, and they are augmented by an HUD, or head-up display, that increases pilot situational awareness, particularly during the approach and landing phases. One of the new innovations introduced by Airbus on this model is the brake-to-vacate system, designed by a multinational Airbus team. It will help ease airport congestion and reduce the amount of time an aircraft remains on the runway. This enables pilots to select a runway exit while the aircraft is making its landing approach. This allows the aircraft to reach a specified exit at the correct speed under optimum conditions. The system will be offered as an option on all 380s by 2007, and will be followed by retrofits available on all other Airbus aircraft families. Reliability and maintainability will be further increased through the use of new technologies, such as enhanced onboard central maintenance systems and variable frequency generators, which simplify the large aircraft's electrical generation network. Another design innovation, using a 5,000 psi hydraulic system, means smaller, lighter pipes and electro-hydrostatic actuators, which ensure that the aircraft can fly and land in the event of a total hydraulic failure. Not only was this aircraft an avionic leap forward for the company, its production process also resulted in change. The Airbus consortium had grown enormously, and in order to streamline decision-making and information flow even further, was restructured in January 2001 into a fully integrated company. French, German and Spanish interests were merged into the European Aeronautic Defence and Space Company, accounting for 80% of shares, while the successor to British Aerospace, BAE Systems, took the other 20%. Construction of new buildings in Hamburg, Bristol and Toulouse went ahead at breakneck speed. Just over a year later, the French Prime Minister Jean-Pierre Raffarin formally opened the A380 assembly facility in Toulouse. Measuring 500 metres by 250, with a height of 47 metres, this massive new facility became the final assembly hall and static test site for the Airbus A380. It was here in January 2005 that the most advanced passenger aircraft ever conceived was put into final production. Four months later, on April the 27th, the first A380 took to the skies, bearing the registration FWWOW, and completes a test flight of 3 hours and 45 minutes. The truly international flight team were delighted with the results, and the full potential of the machine was beginning to be realized. A new dawn in aviation history was breaking. Production of the new A380 got into full swing, but as usual, Airbus did not have it all its own way. Across the Atlantic, their arch rival in the long-haul market began previewing its latest model, the Boeing 787. In a complete reversal of the much earlier philosophies, Boeing elected to build their new aircraft not bigger, but faster, and able to access more airport hubs worldwide.
In Seattle, home to American aircraft building, they're about to start work on up to 3,500 of the new 787 Dreamliners. This is a mock-up revealing for the first time what it will be like inside, with new visual displays and passenger comfort. It will even have a new system that stops turbulence.
Inside the new 787, it's radically different. As a passenger, I think one of the first things you'll notice is space. It feels much bigger. The windows are also larger by some 65% compared with most other planes. And in terms of the environment, it burns 20% less fuel and there are fewer emissions. And that's crucially important for the aviation industry.
Another innovation is mood lighting that can replicate day or night.
Because we have LED lighting throughout the cabin attendants can control all of the lighting with one button and bring it down to what we call a night environment, as you'll see here. And because we have electronic window shades, they can also dim all of the windows. And then prior to arrival, bring all of the lighting back up and open all the window shades.
The plane with extra room for luggage is smaller than the new Airbus A380 and carries around 300 passengers. But with airlines, it's extremely popular. Air Canada is set to buy dozens of the new planes, saying like many other airlines, it's better for its market.
With the introduction of the Boeing 787 Dreamliner, there is a tremendous improvement in comfort for passengers, and it's also one of the best fuel-efficient aircraft that will be available.
I am very happy to be here, and it's a success to have this aircraft here in Le Bourget as planned and with no delays.
The Airbus pundits were unruffled by Boeing's superjet. But in mid-summer 2006, a series of technical setbacks and possible future faults caused the delivery program to be delayed.
We're going to delay further significant delays on the 380. On the other hand, that Christian Streif, our still new Airbus CEO and his team have elaborated already a very comprehensive program for improvement in terms of cash, in terms of EBIT and cost cutting, and obviously improving also in terms of processes.
It would be a very significant event for us to cancel those orders. But, you know, we have to review all our options at this point in time.
With such a huge technical undertaking, breaking so much new ground in so many areas, perhaps setbacks of some kind are inevitable. But coming this far into the delivery schedule, airlines have to look at their own projections and make their own judgments on what to buy and when. As share prices on the recently reorganised EADS Corporation plummet and competitors begin to steal promised orders, things look difficult for Airbus. The company that was once the underdog of the aircraft manufacturing world, yet produced a litany of successful and technologically innovative aircraft, culminating in the largest passenger jet ever, could be facing its biggest challenge yet.